Welcome to my YouTube channel. In this video, I'm going to discuss about the Q data structure. It is the one of the topic under the unit number 3. The subject name is C programming and data structure. C programming and data structure. The syllabus is I'm going to cover the Q, various position of the Q, representation of the Q, inserting the element into the Q, deleting the element from the Q, searching operation. List of terminology. Definition, Q data structure, terminology, example, program and application. It is the Q data structure definition. It is the one of the most important linear data structure and it is working based on the principle of first in first out. Based on the principle of first in first out. Which element inside the Q first, that element should be deleted first. That is the principle of first in first out. We can able to see the real-time example to understand more about the Q. The real-time example, if you are going for cinema theater, you need to buy a ticket from the ticket counter. Buy a ticket from the ticket counter. So you are going to be enter into the ticket counter. If you entered first, you are going to be getting the ticket first. If you entered the second person, then you are going to be getting the ticket in the second. The same thing is going to be happen in the Q data structure. If you entered the first element, that element should be deleted first. If you entered the second element, that element should be deleted in the second position. So that is called as the principle of first in, first out. So if you want to insert the element, we are supposed to use the rear pointer. If you want to delete the element, we are supposed to use the front pointer. So you can see the Q data structure. This is the Q data structure which is indicating the initial Q. So initial condition of the Q is front and rear pointer, both are indicating the -1. Both are indicating the -1. So you can see there are 5 locations are there in the Q data structure. So size equal to 5. Size equal to 5. This is a list of terminology: front, rear, underflow condition, overflow condition, NQ, DQ, searching operations. NQ, DQ, searching operation. Overflow, underflow conditions. Front and rear pointers. Front pointer, just now I said, it is used to be delete the element from the Q. Rear pointer, it is used to be insert the element into the Q. Overflow condition saying Q is empty. Underflow condition saying Q is underflow condition saying Q is empty. Overflow condition saying Q is full. NQ, inserting the element. DQ, removing the element from the Q. Searching operation to find the given element in the Q. To find the given element in the Q. You can see the terminology front. It is a pointer to keep track of the starting element in the Q and it is used to delete the element based on the principle of first in first out. According to the Q data structure, you can see the diagram. The first entered element is A, the second entered element is B, the third entered element is C. Based on the first in first out means the first entered element or first inserted element should be deleted first, second inserted element should be deleted second, third inserted element should be deleted third. Okay, so that is the principle called as the first in first out. Similarly, rear always going to be keep track of the last or end of the element in the Q. Last or end of the element in the Q. Okay, well, it is also working based on the first in first out. Next, NQ. It is an operation to insert the element into the Q based on the principle of first in first out. So before inserting, we need to be check overflow condition. Overflow condition means it is a condition to indicating the stack is full. Stack is full. If the rear pointer indicating the location of 4, the rear pointer indicating the location of 4, then we can able to say the Q is full or overflow. So rear equal to size -1. Size is 5. 5 minus 1, 4. 5 minus 1, 4 and rear indicating the location address of 4. The rear indicating the location address of 4. So 4 equal to 4, condition is true. Body of the if condition is going to be executed. There is a printf in the body of if Q is full, insertion is not possible. Insertion is not possible. Okay, so that is the condition. If rear equal to size minus 1. Next, suppose the previous slide we see this one, if condition, if it is getting failed, that means 4 not equal to 4. Okay, 4 not equal to 4, that means size minus 1 4, 5 minus 1 4. Okay, but the rear, if it is in the location of 4, condition true. Non 4, that is the maybe q indicating the 3 2 1 0 and minus 1. Okay, other than the 4 value, if the rear indicating this particular condition is going to be getting failed, then automatically if is going to be execute the else body only, not the if body. So else body initially, if front equal to minus 1, then front equal to 0. The body of the if is front equal to 0. For the initial position or empty q, it is indicating front and rear pointer is minus 1 address or minus 1 location. So whenever we are planning to insert the first element into the queue, then the rear is going to be indicating the 0 and the front is going to be indicating the minus 1. But according to the front pointer, it is supposed to be indicating the starting of the element. If you inserted the first element, then it is available in the 0. So the first element indicated by the first and the first element indicated by the rear. Okay, so for this particular condition, before inserting the first element in the queue, we are changing the location address of the front equal to 0, because the front pointer always keep tracking of the starting of the element. Okay, so that's why this particular two lines are special case when we are using the empty queue to insert the element. Okay, then next, so before inserting we need to increment the rear pointer, rear plus plus. If I want to insert, I need to be execute directly the third line, rear plus plus. Then the rear will moving into the third location address, Okay, then I can able to insert the element in the fourth location, third address. Fourth location, the address is 3. Okay, so you can see increment is indicated in red, and rear pointer after incrementing it is came from this 2 to 3. So that is the increment. After incrementing, the next line, q of rear equal to value. We are going to be inserting the element through the rear pointer. Rear is 3. That is the q of 3 equal to value. So we are inserting D. Similarly, after inserting the D, again I am incrementing the R, the rear pointer plus plus. Then I am inserting the element. Then DQ, the another operation of Q. DQ means removing the element from the Q. So before removing, we need to be check at least the Q supposed to be contain one element for the purpose of implementing the DQ operation. Okay, so for that one, underflow condition, if rear equal to front, then Q is empty. If this particular condition is true, then Q is empty, then deleting is not possible. Then after deleting, we need to increment the front pointer. So the previous slide, if condition is getting failed, then there is at least one element available in the Q data structure. Okay, so then automatically if condition is getting failed, then else body is going to be execute this one, printf delete colon percentage D Q of front, delete colon percentage D Q of front. Okay, so it is going to be printing this particular A into the output. You can see the output after executing the first line. Output came delete colon A. So after deleting the next line, front pointer should be incremented. Because the front always keep tracking or indicating the starting of the element. Or front element in the queue. After deleting in the front, it is indicating the empty location. It is not a correct. So we are moving into the next element is called as the first element. So we are incrementing the front pointer to keep track of starting of the element in the queue. Similarly, again B. Okay, then one more special case. While we are going to be deleting the element from the queue, if you are going to be found the condition, if front equal to rear equal to 4. So after this one, we can't increment the rear because totally 5 locations are over. But even though there is a number of empty spaces are there, if you want to insert, you need to be increment the rear pointer to the next empty location or to next adjacent location to insert the element. It is not possible here even though the queue is empty. So for this particular special case, we are making this particular queue into the initial position, front equal to rear equal to -1. Then searching operation. If you are giving any one number, and or if you are giving any one character, okay, as an input to the searching operation, it will try to find out whether the same value is available in your queue or not. That is the operation called as the searching. Before going to do the searching operation, we need to check at least one element should be there in the queue. That is called as the underflow. Underflow checked by the rear equal to -1. If the rear is locating the position of -1 here, then there is no element in the queue. So in the empty queue, we can't perform any operation. Okay, so if the condition is failed, if the rear equal to -1, if it is not correct, at least there must be a one element. In the queue. Okay, so if the condition is failed, then it is going for else body here. If body indicated, if and if body indicated in a green color, else and else body indicated in a red color. So initially I am declaring the variable of I under the integer data type. Then I am printing normal text message in the output, Q element found at. Okay, so then the next line for loop is there. So I am going to be checking from the 0th location element up to the rear location element. Started to checking the element from the 0 location up to the rear location. So I am moving. Initial location is front. I equal to front. Up to where? Rear location 3. I less than or equal to rear. From the front location up to the ending value. From the front value up to the ending value, each and every value address is incremented by 1. So that's why I plus. So in this particular for loop will generate the value initially 0, then 1, then 2, then 3. Okay, so this is the output generated from the for loop. So each and every value generated by the for loop, the same number of times body is going to be execute. Okay, inside the body of for loop, if value equal to q of I, I value is 0, 1, 2, 3. Suppose this particular value I provided the input of D. So initially I equal to 0. The D equal to Q of 0 is A. D equal to A is not a true one. It is a failed condition. It is the condition to be failed. So this next line printf, it is the body of the if condition. Okay, so it is not going to be execute because the if condition is getting failed. Again, the for loop is going to be incrementing, then condition checking. Right now the I value is 1. So value is D equal to Q of 1 is B. D equal to B. Condition is failed. So body of the if condition is not going to be execute. Again incrementing. Now the I value 2. Condition is true. Again checking. C D equal to C. Condition failed. So the body of if condition is not going to be execute. Again incrementing 3. I plus incrementing into the 3. Now condition is checking. True. Again we are going to be checking value of D equal to Q of 3. 3. Q of 3 means D. D equal to D. Condition true. Then if body printf percentage D position slash T plus plus I. It is a pre-increment. So before printing the information, I is incremented. That's why we are saying it is a pre-increment unary operator. Pre-increment unary operator. Okay, so then the next one is program. The next one is program. You can see stdio.h, it is going to be supporting the printf scanf. Then conio.h header file, it is supporting the clear screen and getch. Clear screen and getch. Both functions are supported by the conio.h. Then 3 function definitions are there. We are going to be applying the operation on the queue. The first one is enqueue. The first one is enqueue to insert the element into the queue data structure. The second one is the dequeue, deleting the element from the data structure, searching to find the given element into the queue. So 3 function definition or function prototypes are there. The next line, integer q of size, front equal to -1, rear equal to -1. So we are going to be implementing the q size, that is the array implementation. Q we are implementing using array, q of size. Then front equal to -1, then rear equal to -1. Okay, so both pointers are make it as a initial position of empty queue, void main, integer value choice. So this is the declaration and this is the declaration. This particular declaration is called as the global declaration, and this particular value and choice called as the local declaration. So the local declaration is only accessing within the body where the variable declared. Where the variable declared in the same body, it is going to be accessed. It is declared inside the main, it is accessed inside the main. But it is declared outside of the main, it is called as the global declaration. Entire program can access the queue, front, rear. Okay, but then clear screen, while of 1. You can able to see the body of the while. I indicated in the green lines. Okay, up to closing is here. So within the body of while, there is a switch case indicated in the red color programming lines. So the while contains some programming statement along with the switch case. Printf menu output screen, 1 insertion /n next line, 2 deletion next line, 3 searching next line, 4 exit. Okay, 4 exit. So printf enter your choice, scanf ampersand symbol of choice. Okay, if you are entering the choice, number 1, then it is coming into the switch case. Then it is selecting the case 1, printf enter the value to be insert. Then scanf percentage %d value. If I am suppose entering some value, that should be scanned by the scanf, and it is passed as an argument in the enqueue function call. You can able to see the enqueue function definition. If rear equal to size -1, that means before inserting we need to be check overflow condition. If the queue is full, then we can't perform the insertion operation. Else, if front equal to -1, then front equal to 0. For this particular initial condition or initial condition of the queue, you can see the diagram. So if you are inserting the first element, you need to be change the front pointer into 0 for indicating the front element in the queue. So that's why this special 2 line. Then rear plus plus. Before inserting, we need to be increment the rear pointer. Before inserting, we need to be increment the rear pointer. Then after incrementing, the rear pointer is going to be locating the empty location. Through the rear pointer, we are going to be inserting the value into the queue through the rear pointer. Okay, then after inserting, we need to be say insertion is successful. Okay, after completion of this entire function definition, we are going back to the same function called enqueue value. The next line is printf. The printf is getting break of the switch case. The switch case is ended here. Outside the switch case, while loop is there. While loop body. So again it is checking condition is true. Again printf. Again entering the choice 2. Then choice is entered in the switch case right now. Case 2 is selected. dequeue. So function call. Then automatically we are going for dequeue program. Before deleting, we need to check the condition of underflow, front equal to rear. then it is empty. If the condition is getting failed, then else body is going to be execute. That means at least there is one element or more elements. Okay, so the condition is getting failed, then it is going to be executing the else body. In the else body, printf delete %d q of friend. Okay, whatever the element available in the friend, that element should be printed in the output screen. That is the delete and printed into the output screen. After deleting, we are incrementing the friend pointer. After deleting, we are going to be incrementing the friend pointer. Okay, then there is a two more line there. It is a special case. If the front and rear both are equal, if the front and rear both are equal, then we are making front and rear pointer equal to -1. Front and rear pointer equal to -1. It is a special case. If the both pointers are equal, if the both pointers are equal, there is a empty space and we are not possible to insert the element, more elements in the queue. That's why we are changing the front and rear pointer into the initial position. After executing this entire user defined function, it is going back to the same location where the function call executed, the same line. The next line break, the switch case is getting break. Outside the switch case, there is a while body, again true. Always while of 1 means always true. Usually we saw the program while inside the open and close parenthesis there is a condition. If the condition true, it will generate the value of 1. If the condition is getting failed, it will generate the value of 0. Okay, so always while of 1 means always true. This particular while body is going to be executing again and again. The while body is going to be executing again and again. Then there is a menu. You can see this particular three lines, that green color indication. So menu, insertion, deletion, searching, exit. Enter your choice 1. Enter your value to insert 2. Okay, so this is a starting green color program. So whatever we are providing inside the double quotes of printf, it should be available in the output screen same. Similarly, the next second line also, but one dot insert /n. That means then after the /n, it is automatically the output is moving into the next line. Output is moving into the next line. So that's why we are getting the output like this, blue color indication. Menu 1 insertion, 2 deletion, 3 searching, 4 exit. Then this time enter your choice. I am going to be entering the number 3. Entering the number 3. So it is scanned by the scanf. The same 3 is passed to the switch case. The case 3 is selected. Enter the value to search. I am going to be enter some value to find the element is available in the queue or not. Okay, but then scanf, I am going to be reading the percent through the integer value as a input. Then search value. There is a function call. It is going for the function definition. It is a function definition. Before searching, we need to be check the underflow condition, whether rear equal to -1 or not. If it is -1, queue is empty, not possible to do the searching. If the condition is failed, some element should be there. So else body is going to be execute. If the condition fail, else body. Integer I, printf, queue element found at, normal text message we are printing in the output screen. Then for loop, I equal to friend. Friend means always indicating the starting element or front element in the queue. From the starting element, I less than or equal to rear. Rear means it is indicating the last element in the queue. So from the starting element to end of the element, we are going to be searching one by one based on the I++. One by one based on the I++. For this particular for loop will generate from the starting value up to the ending value one after another. Okay, so if in the previous slide I said 0 to 4 or 0 to 3 something. Okay, so here it is a general coding, whatever may be the current position of the stack. Based on that, it is going to be performed. If value equal to q of I. So from the 0 up to some number, from the 0, example according to the diagram, from 0 to 3, 0, 1, 2, 3, that is of totally 4 number. The 4 number value is available in your right hand side, this one, and whatever the value we provided in the left hand side. For each and every time, for 0th location value, first location value, second location value, third location value is going to be changed based on the number of times for loop execution. But the default value we provided, if both are matching, both are equal, then the body of the if condition is printf. Body of the if condition is printf. It is going to be printing the position plus I. So pre-increment. Before executing the printing operation, I plus means after printing it is going to be increment. But plus I means pre-increment. Before printing it is getting incremented. Before printing it is getting incremented. After executing entire the search operation, we are going back to the main function. So in the same line, search value, the second line is break. The particular switch case is getting break. The switch outside is while body, while of 1 true, again printf, menu, insertion, deletion, searching, exit. This time I am going to be enter the value number 4. Value number 4. So automatically we are scanning the value number 4 and it is passed through. In the switch case, the fourth case is getting selected, exit 0. Exit 0. So this particular exit 0 is the keyword. Whenever we are going to be executing this particular keyword, then automatically this particular while loop is getting stopped. While loop is getting stopped because the while of 1 means always while condition is true, always while body is going to be executing again and again. If you want to stop executing, we are supposed to be run the exit 0. Okay, so for that one, fourth case. If you are entering 1, we are going to be inserting. If you are entering 2, we are going to be deleting. If you are entering 3, we are going to be searching the given element in the queue. If you are entering the 4, we are going to be stop the program execution or break the while loop. If you are entering the non number of 1 to 4. If you are entering 5, 6, 7 up to n numbers, then there is no case belongs to that particular number name. Okay, so that's why it is going to be printing the default case printf wrong selection. Printf wrong selections. Okay, I think I done here regarding the queue. Now we are going to see the queue application or application of the queue. The real world example is waiting in the railway station queue for getting the ticket. If you want to travel, you need to be buy a ticket. Now it is available in the online, but olden days we need to be go to the railway station and we need to be stand in the ticket counter queue. Whomever entered first in the queue, they are going to be getting the ticket first. Who entered second, they are going to be getting the ticket second. So based on the first in first out principle, the railway station tickets are provided with the help of ticket counter. The second example, real world, waiting call on hold for the customer care. Waiting call on hold for the customer care. If you are calling to the customer care person is maybe speaking to someone else. Your call is going to be waiting in the queue related to the computer. The application related to the computer science. Okay, so first come first serve job scheduling algorithm in the CPU. Spooling printer job in the printer. If you provided 8 or 9 documents to print through to the printer will get all the input jobs and it is going to be keeping all the jobs in the spooling queue. Okay, so it is going to be provide the printing service based on the first in first out. Network buffer for the device like keyboards. Okay, network buffer and keyboard. Okay, so that is some small mistake. Network buffer and keyboard. If you are using the asynchronous communication between the two computers in the network, the computer one or sender may be sending very fast, the receiver may be receiving very slowly. Okay, so adjusting the data transmissions, fast and slow computers, the slow computer has the queue buffer. It is going to be storing all the information and it is going to be reading first input, first and second input, second, third input, third time. Okay, so based on the service, it is based on the first in first out service, it is going to be performed. Then memory management also one of the application for the queue, one of the application for the queue. I think now I done with the queue data structure. So you can able to see all the topics in the queue data structure. Whatever we discussed, I will go through once. Listen properly. So in this unit number 3, we saw the queue, where is position of the queue, representation of the queue, insertion, deletion, searching operation. So definition we saw queue data structure, terminology, example, program, application of the queue. Okay, so the data structure I indicated initial position front equal to rear equal to -1, front equal to rear equal to -1. For insertion rear, for deleting front pointer. Okay, then list of terminology, 7 terminologies are there: 2 pointer, 2 condition and 3 operation. Then front pointer example and rear pointer example data structure. Then NQ insertion operation, then DQ deleting operation, DQ deleting operation, then we saw the searching operation, then we saw the program. Under the program there are 3 user defined function for the 3 operations. Last we saw the example or application of the queue. Thank you for watching my video.